Now we're going to have some fun because SPSS makes comparing the means from different groups so easy that you can ask all kinds of questions and try to get to the bottom of a challenging research question. After all, this is the heart of what appeals to some of us about being able to do research. Okay, I'll admit I'm a research geek. You might be too after you see how easy this is. Depending on your particular preferences for learning, there are several ways to approach this lecture. I suggest that you download these two documents and work through them, just as we would work together in a face-to-face class. Some of you may want to just watch all the way through and then watch it a second time, pausing to do the analyses as you would in a face-to-face class. Whatever works for you. But at the end of this, you need to take on a challenge that will be SPSS assignment number 4 and answer the research questions and put together your answers in kind of a formal way. So let's look at the challenge. This is why you needed to download the challenge so you don't have to read all of this off the screen, but I'll go ahead and talk through it. A Midwestern state has implemented a new teacher evaluation system. And of course, at the end of the second year, there are a lot of questions being asked along with some grumbling. The state education regents want to know if there are any influences on the evaluation scores. In other words, are there factors other than teacher performance that influence the evaluation scores? Perhaps where the teacher teaches makes a difference. Perhaps it matters whether the same administrator does the evaluation 2 years in a row. Perhaps the gender of the teacher has an influence. You've been asked to investigate this situation. You're going to base these decisions about what to ask, and notice that the main question that's really being asked. Pause a minute and think about all the factors that could possibly influence a teacher's evaluation. I bet you could make a list of 10 or 12 influences. A researcher always has to do a cost-benefit trade-off, though, and choose which factors to investigate. You base these decisions on your expertise, other people's research, and the time and other resources you have available. Look at the data file for this lecture. Excuse me. I randomly selected 25 teachers from across the state. These are the factors I decided to collect information on to answer the question. The first is gender. Perhaps administrators are influenced in rating teachers by whether the teacher is male or female. Next, I wondered if the teacher's years of experience influence their evaluation score. I would expect that teachers with more teaching experience would have higher evaluations ratings than those just entering the profession. Then I wondered if the challenges of teaching in a school with high poverty are reflected in evaluation scores. High poverty schools are designated as Title I schools, so I used that as a proxy for poverty. I wondered if having the same administrator do the evaluation for 2 years in a row would influence the evaluation score. Logic would suggest that a teacher could take feedback from the first year and improve during the second year if the evaluator was a constant. I knew everyone was concerned about job satisfaction with the new evaluation system, so I used a job satisfaction survey that had been given right before the evaluation system was implemented. Satisfaction rating was 1 to 10, with 10 being the highest, and I gave it again at the end of the 2 years of implementation. We're not going to use this data in this example because it involves dependent scores. This example and lecture is about independent t-tests, but we'll use it for SPSS assignment number 5. You can anticipate that we'll come back to this for the next assignment. Finally, I had the evaluation scores out of 25 for each teacher. For the regents and full points in the assignment, we have some pieces that we're going to put together. Look at your assignment sheet. Let's start with task number 1. We need to develop specific research questions to guide the work. So here's how I would start. A random sample of 25 teachers from our state was gathered. For each teacher, researchers gathered data about the following factors, which were chosen as possibly influencing the evaluation scores. And then I list them out. Researchers then developed these specific research questions. And these are the questions I would come up with. Uh-oh, that doesn't look good. Does teacher gender have an effect on evaluation score? Does teaching experience have an effect on evaluation score? Does teaching in a Title I school have an effect on evaluation score? Does having the evaluation done by the same administrator for 2 years, that should be, have an effect on evaluation score? Next, I'm going to look at my data and make sure I've got the right data for these questions and that I haven't left anything out. This is where I have to do that cost-benefit analysis. Right away, I notice that I have 20 female teachers and 5 male teachers. That's a problem. I simply cannot compare a group of 20 with a group of 5. Basically, my whole random sample is female. I don't have the right data to answer the question. For question 1, I should have anticipated this and done a stratified random sample so that I had close to equal numbers of males and females. In case you're wondering, I made up this whole data set. I wanted you to notice that there are some questions you cannot answer with the data. I expect you to notice things like that and not plunge into an analysis that makes no sense. Always, always, always think about what your data represent when you are doing analyses. So these are the questions I can actually use to address this data set. If this were an EPY assignment, I'd be sure to craft a statement that I did not do an analysis for gender because of the lack of variability in the data. So I would say something like this. The random sample of teachers consisted of 20 female teachers and 4 male teachers. No analysis was done because of the lack of variability in gender. And that's how I would craft it. So I have my data. I'm using SPSS, so I know that I need to replace words with numbers so that the analysis can run. So I need to come up with a coding scheme for each of these variables. Remember that it doesn't matter what number I use. I could use 5,294 and 10,863 if I wanted to. However, it is a convention to use 0 and 1 and add 2, 3, 4, and so forth if I have more groups. Keep in mind that your audience may look at your printout and your results and think that some strange number you used for your code means something. So stick with the convention. And here's what I'm going to come up with to code these. I'm going to use 0 for male, 1 for female. Years of experience. Up to 5 years of experience, and including 5 years, and 1 for more than 5 years. Did they teach in a Title I school? 0 for no and 1 for yes. Same administrator for 2 years in a row. 0 for no and 1 for yes. This is not a class in how to use a spreadsheet, so I'm not going into detail on how to replace the values in each cell in the data set I gave you. If it is confusing to you, simply type what you want in each cell. I use the find and replace in the spreadsheet, and it goes in very quickly and accurately. And now I have my data set ready to take into SPSS. This all may seem like a lot of work, but real data is messy. Real data are messy, I'm sorry. It usually takes much longer to get the data ready than it does to run any kind of analysis. Be prepared for that. Clean, usable data only exists in EdSite class examples. Now it's time to set up my SPSS file. Open an empty SPSS data file. Always start with the Variable View tab so that your columns, which represent your variables, are properly labeled and behave as the kind of variable you need them to be. For the variables which are actually categories, such as gender or years of experience, you will need to put the labels in for each category. Click on the value cell and a dialog box will appear. You've done this before in this class. And now you go to the Data View tab and paste your data into the spreadsheet, or from your spreadsheet, or you import it into SPSS. And now we're ready for the fun part. Let's look at the research questions we have. For each of these questions, I can compare the mean from one group with the mean from another group. I also know that each sample group is going to be independent of the other group. In other words, from the population, I sampled 25 teachers. Of those 25 teachers, one sample group has 5 years or less of teaching experience, and one sample group has more than 5 years of teaching experience. There's no overlap. The sample groups are independent of each other. That goes for gender, teaching in a Title I school, and having a 2-year-in-a-row administrator. So, my null hypothesis for each of these questions is going to be that there's no difference between the two independent groups' means. They're totally independent samples. So this is the moment we've all been waiting for. And the good news is I'm not going to do all those calculations by hand. Welcome to the 21st century. So we're going to start with question 2. Let's look at question 2. I have 13 teachers with 5 years of teaching experience or less, which I'm going to call group 1, and 12 teachers with more than 5 years of teaching experience, which I'm going to call group 2. Okay, so let me show you how to do this in SPSS. You go to the Analyze menu, and then you want to compare the means. And you want to choose an independent samples t-test. And you're going to get a dialog box that pops up. First of all, you've got to choose your test variable. This is your dependent variable. And in this case, we want to know what the effect of teacher experience is on their evaluation score. So I clicked on that, and I added it over as my dependent variable. Now I have to choose my grouping variable. Remember, I've got the teachers grouped into those who have 5 years or less experience and those who have more than 5 years experience. And that is this grouping variable. So I'm going to put it in as my grouping variable. Notice that it pops up with 2 little question marks. That's because I need to tell SPSS what my groups are. Group 1 is my teachers with the least experience, and I designated those with a 0. That's their code. Group 2 is my teachers with 5 years or more experience, and their code is 1. Don't worry about a cut point. That's if you want to say take this group of teachers above this mark and this group below. In this case, we've already defined our groups. So I'm going to click Continue. And now I have years of experience as my grouping variable, and I've told SPSS what the different groups are. Now, I'm going to click on Options because I'm going to set my alpha at 5%. SPSS has a default confidence interval percentage of 95%, which is my alpha at 0.05, which is great. So I'm going to go ahead and leave the default. If I wanted to change it to 10%, then of course I would drop it to 90% in this box. This part of the dialog box about missing values is in case I have a teacher who perhaps I don't have their years of experience, but I have an evaluation score and they're part of my data set. I can tell SPS how to handle cases that are missing different things. So don't worry about that, how we exclude cases and different things like that, because remember, this is a cooked up data set that I made, so you're not missing anything. So I click Continue. Now I've set my probability, I have my dependent variable, and I have my grouping variable in here. So now I'm ready to tell SPSS to do all of the work for me. And I get a printout that looks like this. Okay, let's look at what we've got here. Here it is, so that we've got the right one. Let's look first of all at the group statistics area. I've got my dependent variable listed here. Then I've got a group where the teachers have up to 5 years of experience, 5 years or less. And there are 13 people in that group. Their mean score on the evaluation is 15.85, and their standard deviation is 1.676. In my other group, which is the teachers with more than 5 years of experience, there are 12 of them. Their mean is 19.25, and their standard deviation is 1.712. So that's my information about those two groups. Now I want you to look at the independent samples test box down below that. You'll remember that with the independent t-test, we have to worry that the variances in both groups are roughly the same, that they're homogeneous. So we needed to do a test for the homogeneity of variance. SPSS automatically does that for us, and it's called Levene's test for the equality of variance. What you need to do is remember that your null hypothesis for the test of homogeneity of variance is that the variances are the same, and you're looking at how large that ratio is when you divide one variance by the other variance. Levene's test for equality of variance shows us that. This F score here is your ratio right there, and it's 0.016. That is darn close to 1, which is a good thing. It means that the variances are the same in both my group 1 and my group 2. Look at the significance. It's way, way over a level of 0.05. That is cause for celebration, because it means that my null hypothesis that the variance is the same, I'm going to keep it. I don't have an F statistic that's high enough or significance that's low enough to reject it, and that is a good thing. I'm a happy camper. My equal variances are assumed. The nice thing is that SPSS automatically runs the test both ways. It runs it with the equal variances being assumed and the equal variances not assumed. But you have to know which of these two lines to use when you report out. In this case, my ratio is very, very low. My significance is 0.901, so I'm going to keep my null hypothesis that the variances are the same, and I'm going to use this top row going across here for reporting purposes. I don't have to use this one because I've got equal variances assumed. So let's look and see what we found out. I've got a t-score here. Here's my test statistic right here. It's negative 5.022. What that means is that group 1, their mean is 5.022 standard deviations below the assumed mean, the mean of the other group. So my degrees of freedom are listed here. I had 25 people in my sample, so my degrees of freedom is 23. Let's look at the significance. Great. This means that my test statistic, was above that critical area for rejection. And it means that I can reject the null hypothesis of the two groups being their means being the same and it's less than 0.05 for my probability cutoff. SPSS also gives me the mean difference between the groups. In other words, the difference between the mean for group 1, 15.85, and the mean for group 2, 19.25, is 3.404. Here's my standard error of the difference. Remember the 3 steps you had to go through to figure that out so that you could run your test statistic? And it also gives you a confidence interval. Now notice with a confidence interval that the confidence interval in this case goes from negative 4.806 to an upper of negative 2.002. In other words, we're pretty certain that 95% of those teachers' eval scores are between negative 4.81 standard deviations below and a negative 2.002 standard deviations below. So 95% of those teacher means for their eval scores fall within these standard deviations. What is really wonderful about this is that 0 is not in this confidence interval. If 0 was in this confidence interval, then my significance would be above 0.05 and my test statistic would not be statistically significant. It wouldn't be in the area of rejection. So that's how these pieces work together.